Welcome again in this lecture of our controlling course. In this lecture, we will take a quick overview on the power conversion methods. So we want to go on depth of each type of them, but we will take a quick overview and this information will be very important for us next lectures. So let's here start with this question. How electrical power can be converted. So we want to know how electrical power can be converted from its forms to other forms. So if we have an AC power source and we want to convert from it to a DC power source, so we will use a rectifier circuit. And if we want to convert from DC source to another DC source, so from a DC level to another DC level, we will use a Chopper circuit. And if we want to return back from DC to AC, we will use an inverter. So there is a device which consists of electronic circuits is called an inverter. And if we complete or if we need to complete this cycle to convert from AC level to another AC level, we will use a transformer. So let's go on each type of them. How can we want or how can we convert from AC level to another AC level? So we will use a transformer for doing this. So according to the turns or the turns ratio between the primary coil and the secondary coil, here is our source and here is the load. So there will be a conversion of energy from AC level to another AC level. But we want to know or we must to know that the input frequency and the output frequency will be the same for this transformer method. And this is a sample of our single phase transformer, and this is a single phase transformer, and we can have also a three phase transformer. So the three phase transformer will have a three here coils for the input three phases for the primary windings, and the secondary windings also there are three transformer or three coils here. So this is the phase one, the blue and the yellow and the red, and the blue for the secondary and yellow and red for the secondary also. So this is an example of the three-phase transformer on real fact. So it's the easiest type of conversion. So when we convert here from AC to AC, so it's the easiest one. It don't need a complex circuits or complex electronics, so it's done easily here. And as we have told or as we have talked about, the input and output signals will have the same frequency. So the second type is the AC to DC conversion. So we will use a circuit which is the bridge rectifier here for converting it. And this is our input sine wave which have a positive half and negative half, and our job is to convert each negative halves here to the positive region. So the job of these four diodes is that to convert the negative half to the positive half. And after converting it, and all of our halves here will be on the positive region, so we will have a smoothing capacitor here. So this capacitor will charge and discharge to get here our signal, or to be a smooth signal, or to have here implementation of it to get a smooth DC level. So this third one is the DC to DC conversion. And the DC to DC conversion is done by a circuit which called the Chopper circuit. And the Chopper circuit have three types. The first one is called post, and the post converter have the output DC level higher than the input DC level. So this at the post, the output signal will be larger or higher than the input signal. And the second one is called the buck converter, and the buck converter have the output signal lower than the input signal here. and this is the puck, and the third one is called puck boost or boost puck. So it can increase the output voltage or it can decrease it related to the input signal according to our need in our circuit. So it's called puck boost. We can increase the output or decrease it according to our need. So we have the boost and the puck and the puck boost. So we have an application here, so we use this boost circuit for the PV solar system. So if we have this solar system here, we can take a quick overview on it. So this solar arrays here will have the current or will have the electrons follows from here to the input circuit, as this is the electrical power which follows from our solar array system to our input signal. So when the sunlight falls over this solar cells, there will be a free electrons here which goes to our input circuit. So this will make an input current or input voltage to our circuit. So this current will goes at this position or it will goes through these batteries. So the electrical power from the solar cells is stored on some batteries. So it's a DC current which is stored on these batteries, and after storing the DC power, we will convert it again to AC power. So after converting it to AC power, we will have a transformer here, and this transformer can step up the voltage, so we can use our voltage here or our power source to feed our homes or our loads or any load we want to feed it. So there is a problem here. The sunlight which falls over the solar array here can vary during the day, and when it varies, the voltage which follows from the solar array will vary also. So when the voltage vary, so the voltage produced from the solar array system may be 20 volts, but the batteries here have a constant value of voltage which may be 24. So this will cause that the potential here or the voltage at this point will be higher than the voltage at this point, which means that the current will follow from these batteries turns back to these solar cells, and this reverse flow of power may damage our system, as these solar cells is designed to follow the power from it to the batteries. So to solve this problem of damaging our design, we have the boost converter here. So the boost converter increase our input voltage from our solar cells to a specific value, and this specific value is the value which our batteries need, so it's a constant value according to the voltage of our batteries. So this is an application of using our boost here converter to increase the voltage to a constant one. So the fourth type is the DC to AC conversion, and we use an inverter, which we will see now. So if we have the input signal is a linear DC one, and we will use our inverter here to increase the voltage, or here to convert our voltage from a smoothing DC to a sine wave here, which is an alternating current. So this is a shape or a model of our inverter. So we can plug our input DC voltage and we can get our output AC voltage from the other plug. So we have an application or a problem here. If we have a television and the ceiling fan, so each of them works on 220 volts and 60 hertz. How can we make adaptation of this system or of these loads to work on 110 volts and 50 hertz only? So easily we can use a step-down transformer to minimize the voltage from 220 to 100 here 10 volts. So this is a transformer which we can use, and the television here works on a DC. So here the television circuit here converts the AC level to a DC level, so it won't be a problem for our television here to decrease the voltage from 220 to 100 here 10 volts, as its internal circuit works on DC level, not AC level. So for television this system may be good one. But for the ceiling fan, this system won't be a good one. But why? Because when the voltage is decreased, here we have decreased the voltage from 220 volts to 110 volts. And the voltage equation at the current times 2 pi times the frequency times the inductance of our load. So here at this condition, it will be the inductance of the coils of our fan. So when the voltage is decreased here, the frequency also of our fan here will be decreased also. So the voltage, or this equation, is a constant equation. So when the frequency is decreased, the current will be increased. So when the current will be increased, so it will be increased related to the rated current at which this fan is designed. So the coils of these fans is designed to take a rated current. So when this rated current is increased by a value, so this will be a problem for our fan. So it may be burned out, or after a time it may be hotter than the usual or its usual temperature. So at overall, this fan may be burned out according to the increasing current, or the efficiency will be decreased for our fan. So how can we solve this problem of decreasing our efficiency? So to solve this problem, we can use a device which is called a stabilizer. So what is this stabilizer? So a stabilizer is a device which will have the input voltage and input frequency. So we give it an input voltage and input frequency, and it gives us output voltage and output frequency, or our required output frequency. So if our here input frequency is 50 hertz, but our fan works only on here 60 hertz, so it will be good. So this stabilizer will give us our output frequency which we need, and it gives us our output voltage we need also. So this will be good for our fan, as we have got our output frequency which we want. So when the frequency is constant, the current will be constant also. So there will be no problem. So the internal design of the stabilizer is that it converts the AC power using a rectifier to a DC power, and it turns the DC power again using an inverter, which we have illustrated, to an AC power again, but with our needed voltage and needed output frequency. So this is our stabilizer, and this is a design of it, and it have also many shapes. So it was our lecture today. Thank you for watching, and see you next lectures.